Welcome back, all my aspiring mathematicians. Today we are going to deal with system of linear equations. Now, what is a system of linear equations? A system of linear equation is a set of two or more linear equations in the same variable. And once you have a system of linear equations, usually you have a solution, but there are cases when there is no solution. Usually, a solution of the system of equation is an ordered pair that is a solution of each of the equation in the system. There are three ways of solving system of linear equations. You can solve it graphically, you can solve it by elimination, or you can solve it by substitution. Today I'm going to show you how to solve a system of equations graphically. If we are graphing a system of linear equations, there are also three types of solution. First one is one solution. The one solution usually occurs when you have two linear equations that are intersecting at a point, and for the one solution it is usually just an ordered pair. That is the point of intersection of the two linear equations. Second one is no solution. When you have no solution, therefore it means that none of the graph of that system of linear equations are going to meet. They are going to be parallel. The third one is simply infinitely many solutions. I'm now going to graph all these three types for you. So let's get right into it. The first one, we're going to use y is equal to -1/2 x minus 2, and the other one is y is equal to -3/3 x, and that is plus 2. If you don't know how to graph a linear equation, you can go back and watch my video on how to graph a linear equation, and that will help you. So when you are given a linear equation, you know you have to identify your slope, which is your m here, and your b. You need these 2 points. So for the first one, we have -2. So we are going to start at -2. The slope is -1/2. So down 1/2 or up 1/2. Up 1/2. Now you are going to connect all your points. And this is, you have to label your graph, -1/2 x minus 2. Put an arrow at the end to show that the graph do continues. We are going to graph the next one. So this is our b, which is +2, which is right here. The slope is -3/2. So down 3, 1, 2, 3/2, 1, 2, 3/2. Or up 1, 2, 3 to the left 2. And we are going to connect our points now. We just need 3 points in order to connect a line for any linear graph. And we will continue to the end of this grid paper. Okay, you put an arrow at the end. Arrow at the end, you label your graph, y equals -3/2 x plus 2. You will notice that these two lines intersect at this point right here, and the point of intersection here is simply 4, -4, and that is your solution. So you simply write for your answer here, solution, and you can write the word solution underneath the bottom, and you can do this. Draw a cloud. I always like to draw a cloud. So what this is telling you is that if you plug in 4, -4 in each of these equations here, it is going to be true for each one of these, and I will demonstrate for you. So let's choose y is equals to -3/2 x plus 2. Y is -4 equals -3/2, and the x there is 4 plus 2. We simplify this, it'll be -6 plus 2. The right side is going to give you -4, and the left side is -4, and yes, that is true. Let's try for this one. So we have y is equal to -1/2 x minus 2. We are simply substituting here. negative half times 4 minus 2, negative 4. This is going to give you negative 2 minus 2. On the right is negative 4. Negative 4 equals negative 4. Yes, the number on the right is equal to the number on the left. So this solution satisfies the solution for each one of these two equations. And that's what it means. This is what the graph will look like graphically for a one solution, and this is your solution. Let's graph the next set of system of linear equations. And so we have y equal 2x plus 2 and y equal 2x minus 2. The y-intercept is at 2, so let's start at 2. And our slope here is positive 2, up 2 over 1, up 2 over 1, or down 2 to the left 1, down 2 to the left 1. And when we graph those, we are going to connect our points now. And you notice that if this is the first one, the slope is positive, so you can label it as y equal 2x plus 2. And the next one we are going to graph is y equals 2x minus 2. And because you have a minus 2, your b is right here at minus 2. You are going to go up 2 over 1, up 2 over 1, up 2 over 1, or down 2 to the left 1, down 2 to the left 1. And you are going to connect your points. And this is what our graph is going to look like. You will leave your graph y equals 2x minus 2. What do you notice here? Two graphs are parallel to each other. And because they're parallel to each other, there is no solution. And so you will now say that this is no solution. And you can be specific and right because the lines or the graphs are parallel, meaning that they did not intersect. Only when they intersect, then you have a solution. So this is a situation where it is not parallel. Another thing I must point out to you is that let's look at the difference with the two sets of equations. The second equation, both slopes are the same, but the y-intercept is different. So when the slopes are the same, so you have same slope and different y-intercept, then there is no solution. Hence, no solution. Because the lines are parallel. The first equation that we did, looking at the equation, you have different slopes and different y-intercepts. And when you have that occurring, usually the lines will intersect at a point. When the graph has the same slope and different y-intercept, you will not find that the graphs are intersecting at any point. They are going to be parallel. Now let's get into the third one. The third set of linear equations that I'm going to graph is going to be y is equals to negative 2/3 x plus 4. And the second one is going to be 2x plus 3y equal to 12. What do you notice here? Hold up, wait. What do you notice here? The first equation is in the form of y equals mx plus b. But the second one is not in that form. It is in the standard form. So you have to change the second equation into the standard form before you are able to start graphing. Guess what? If you don't know how to change it, you can go back and watch my video on changing from standard form equation to slope-intercept form equation. Now, if you know how to do it, let's get right into it. We are going to start with the first equation. It is y equals negative 2/3 x plus 4. We are going to start at 4, which is our b, and our slope is negative 2 over 3. So we're going to go down 2 to the left 3, down 2, to the left 3, or we are going to go up 2, to the right 3. Up 2, to the right 3. And we are going to connect our points. Y equals negative 2/3 x plus 4. Now let's change the next one. So we're going to change this into slope-intercept form. So we will have 3y is equals to negative 2x plus 12. And the next line is y equals negative 2/3 x plus 4, because we're going to divide by 3. Whoa, what do you notice? Hold up, wait. You'll notice that both equations are the same. And because both equations are the same, you can literally know that any point on this equation is going to be the same for the other one. Since you have both equations on top of each other, you will end up with infinitely many solutions. When you have infinitely many solutions in a system of linear equation, it simply means that it is a dependent system of equations. So you will notice here, looking at both equations, this equation and this equation, the slopes are the same and the b, or what we call the y-intercept, are the same. So when you have the same slope and same y-intercept, then you will end up with infinitely many solutions. These are the 3 basic types of solution that you will encounter when you're graphing system of linear equations. I hope that this has helped you tremendously, and not only will you have to graph it, but you can look on the equations that are given to you and identify when you will have a solution, which is in this case when the slope and the b-intercept are different, and when you will have no solution, which is simply when the slopes are the same but the y-intercept are different and the lines are going to be parallel. And you can also identify when you will have infinitely many solutions, because you will have the same slope and the same y-intercept. Please go ahead and watch my video on solving system of linear equation by elimination. Thank you for watching, and cheers now. Bye.